Today we're going to talk about hypothesis testing, p-values versus alpha and critical region in the rejection region. So far, we've made our decision in a hypothesis test by comparing our p-value to our chosen significance level alpha. A p-value represents the chance of getting our sample result, or something more extreme, given the initial claim about the parameter, or our null hypothesis. The decision-making rule using in the p-value is reject the null hypothesis if the p-value is less than or equal to alpha, or fail to reject the null hypothesis if the p-value is greater than alpha. Another way to make a decision to see whether our test statistics, our standardized result, lands in the critical rejection region. We determine this region based on two factors, significance level alpha, and whether we have a left-tailed test, a right-tailed test, or a two-tailed test. If our test statistic lands in the critical or region or rejection region, we reject the null hypothesis. If the test statistic fails to land in that region, we fail to reject the null hypothesis. So we're going to go through the three different ways that we could make our decision. First, examples using p-value versus alpha to make our decision. Examples using critical region, rejection region to make our decision, and connecting the two ways to make decisions using sample and distributions. So we want to look at example 1, bad potatoes. Based on the sample, is there evidence to conclude more than 8% of potatoes in the shipment have blemishes? So we need to go back and see our hypothesis test problems, number 2 for p-hat. And for this one, our p-hat was 47 over 500, which equals 0.094. We used a significance level of 0.10. And for this, our null hypothesis was p equals 0.08. Our alternative was p is greater than 0.08. So let's go ahead and go through A, examples using p-value versus alpha to make our decision. So when we did this gave us, looking back at our example before, a z-value of 1.15. We had a p-value, looking back at that example, of 0.124. Our significance level, like we stated, was 0.10. And here, when we stated our conclusion, our p-value was greater than alpha, because our p-value was 0.124, which is greater than 0.10. So we failed to reject the null hypothesis. Not sufficient evidence to suggest. %8 of the potatoes in the shipment have blemishes. So that's something we already did back when we started hypothesis tests. So now we're going to do letter B. Examples using critical region, rejection region to make our decision. So here, this was a right-tailed test because it was greater than, and our alpha was 10%. And we had a z-value of 1.15. Now, since this is a right-tailed test, we need to find a z-score so that 10% of the area lies to the right of the critical value. Okay, so this is a right-tailed test. And we need to find a z-score so that 10% of the area lies to the right. So let's go ahead and draw a picture of that. So I have 0 here. And my z-score when 10% lies to the right would be 1.29. So you can either use your table of values or your calculator to find that. This has an area of 0.10. And now my critical value that I found when I did my hypothesis test was 1.15. And 1.15 would be right here. 1.15 does not fall within my critical region, so I fail to reject the null hypothesis. And just a reminder on how you can find that z-score of 1.29, inverse norm of 0.9 equals 1.29. So then bringing these together, my C, the third part, my z-score of 1.15 is not in the to the right of the 1.29 rejection region, so I fail to reject the null hypothesis. So my z-score of is not in rejection region, so I fail to reject my null hypothesis. And the p-value, bringing them together, of 0.124 is greater than 0.10, so I fail to reject the null hypothesis. And remember, the p-value is the probability we get our result or something more extreme given the initial claim about the parameter. So it's like the conditional probability. The probability that p hat is greater than or equal to 0.094, given that my parameter p equals 0.08. Let's go ahead and look at another example. Home preferences. Based on the sample, is there evidence to conclude the proportion of Californians who prefer single-family homes is different from the national proportion of 0.71? So we need to see our hypothesis problems, and this was number 7. For this, with number 7, my p hat was 1,682 over 2002, which equals 0.84, and alpha was 0.01. My null hypothesis was p equals 0.71, and my alternative hypothesis was p is not equal to 0.71. So let's go through A, which is what we did with our hypothesis test. We get a z of 12.8. We were using an alpha level of 0.01. Our p-value was 1.1 times 10 to the negative 37. So that's about 0. So here my p-value was less than alpha because about 0.0 is less than 0.01. So we reject the null hypothesis. There's very strong evidence to suggest the proportion of Californians who prefer single-family homes is different from the national population. Okay, so let's go ahead and look at B. So with B, we have our Z value from A, which was 12.8. Our alpha equals 0.01. But we need to remember, we need to divide that by 2 because this is a two-tailed, and you get 0.005. So let's go ahead and draw this. So we would have here this area here would be 0.005, and this area over here would be 0.005. So we need to find our critical values, and that would have been for this one, negative 2.576, and this one would have been 2.576. So from here, we know that our Z is 12.8. So our Z of 12.8 is like way over here. And we reject the null hypothesis because this test statistic lands in the rejection region of HO. Okay, and now when we put these two together with C, the Z-score of 12.8 is in our rejection region. And our p-value of about 0.0 is less than 0.01, so we also reject our null hypothesis. Landing in the rejection region lands to a p-value being less than our alpha.